Kafka Summit San Francisco is officially open. Please welcome to the stage today's MC, Head of Kafka Developer Experience at Confluent, Tim Berglund.
Good morning. Good morning. Look at all of you. You know, when we started doing these 15 years ago, we never thought they'd be this big. No, actually, I heard a couple laughs. That was good. It was good. We're getting warmed up. It's early. It hasn't been 15 years. It's only been 2. The first one was here in San Francisco in 2016. And just 2 years later, there are going to be 1,000 of you here today. And it's pretty exciting. I'm delighted to be here and to be a part of it. And I'm glad you guys are here too. We've got a lot lined up for you. Let me give you an idea what to expect before we get things kicked off with our first keynoter. I'd like to begin by thanking these people. This is your program committee. Technically, I'm also on the program committee, but you're looking at my face right now, so there's no reason for my face to be on that slide. These are the people together. We have sifted through a tremendous number of proposals to come up with the program that you see today. And some of these people are here. If you see one of these people, you could give them a warm handshake and a thank you. Approach slowly. Don't run up to them. You know, that could be startling. But yeah, say thank you to them. So they've done hard work. Now we have 4 tracks today, which is new. If you've and by the way, who has been to a Kafka Summit before? Can I see hands? You have to hold them high because there are lights. Okay, hands down. Who has not been? So many new people. Yes. Okay. So you didn't even know this is new. If you've been before, this has been a 3-track institution, but we've got 4 today. We've got stream processing, pipelines, internals, and one called the business case, which is kind of about the business implications of Kafka deployments. Check it out. Whatever you're interested in, any session you like, you don't have to have signed up. Just walk in. And you don't have to worry about what you've missed out on because we are recording these, and it's going to be a few weeks before the recordings are available online, but they will be. We will email you. You will know if you are signed up for this thing. You will absolutely know. We'll send you an email. You'll be able to watch all the videos online later. So don't worry about what you haven't attended. Just pick your favorite thing. Now, Wi-Fi. Everybody wants it. You have doubtless noticed there is an SSID floating around called Kafka Summit. That's not hard to find. The password is the word streaming, all lowercase. I have joined this network this morning, and it seems to work. So check it out. If you want to get on that now, since I said Wi-Fi, like heads go down in phones, you know, I'm the same way. I do it too. You can download the mobile app. This is the Kafka Summit San Francisco mobile app. If you want to DDoS the network right now, we can all do that. And this is important. It's not because we actually want to bring the network down, but it's important because you can see the schedule and you can rate the session inside the app, and that's very important. I am not a speaker beyond being on the stage right now at the summit, but I am frequently a speaker, and I know it's really important to get that feedback. So please give that back to the people that you're listening to. Give them a rating, give them an honest rating, and that will help them know what to do next time. Also, you can network with other attendees, you can share photos and things like that inside the app, and you can see the code of conduct. That's inside the app. Please check that out. And more importantly, there's nothing in the code of conduct that's going to be a surprise to really anyone, but please read it. And if you see anything that looks like a violation of that, you want to look for a person in one of the, what color is that? It's kind of, I'm going to call it a light blue-green. I'm not very good with color words, but it says Confluent on it. You can find somebody with that shirt and let them know, and they'll help you escalate. Social media. I would love for you to tweet and Instagram pictures of this event all day long, please. Do selfies with your friends, take pictures of the food, take pictures of the sessions, take pictures of the AV gear. I don't care what you do, just do that because it's fun and people like to see that. If you use this hashtag, Kafka Summit, that's the official hashtag of the event, there's this printed wall thing down in the expo floor downstairs. It's kind of down on the far side. And pictures that get grammed or tweeted with this hashtag are going to get printed out, and today and tomorrow a picture is going to emerge. An actual physical like poster will be made from your pictures. So if that little bit of coolness is not sufficient motivation for you to tweet pictures, I don't know what will be, but I'm excited to see how that works. Of course, a thing like this doesn't happen without our sponsors. We are very grateful to these people for their participation and their support in making this event possible. And many of these are downstairs in the expo floor, so make sure you go and talk to them and see kind of what they're all about. We recommend that. Now, our first keynoter today, our first keynote is going to be Jay Krebs. Now, he's kind of a man here who needs no introduction, but I don't care. I'm going to do it anyway. Jay was lead architect for data infrastructure at LinkedIn years ago, where he was co-creator or creator of projects like Voldemort, Project Voldemort. Anybody, any Voldemort users? Yes, shout out in the back. Okay, Apache Samza users. More hands, look at that. This other one he co-created, Apache Kafka. Please, no, don't put your hand up. That's why we're here. Anyway, it's my pleasure to introduce Jay Krebs.
All right. Voldemort, that's really bringing me back. Welcome, everybody. I hope you're all as excited to be here as I am. So I'm going to be talking today about events and about event-oriented architecture and how it's affecting the systems that we're building, software applications. This is not a new idea, but it's something that I think is really coming from the background into the foreground now. And so the title of my talk, Overcome by Events, this is actually a military acronym, OBE. And so if your plan is overrun by the course of events, then you can say it's OBE, right? And I think that's actually something that's happening in the world. It's happening in a lot of different areas and systems. I'll try and outline some of those. They're kind of becoming OBE. And so let me start and say, what is an event? This is an idea that is almost so simple that when you explain it, it sounds silly. An event is just something that happened. It's just something that occurred. And that seems pretty fundamental. Like if you think about what's an event in a business, it's a sale or an invoice or a trade. It could be something low level, like some low level thing an application does, or it could be something high level, like a customer experience, something very rich. But if you think about where are events, where have they been? They haven't really had a proper home in infrastructure. They've been implicit. They're kind of hidden. So if you look in your code, there wasn't really a lot of events. If you look in data infrastructure, there's no real representation of this concept. What we've had is databases and programming languages and RPC layers, but we haven't really had events anywhere in our stack. And I think increasingly they're becoming visible and they're coming to the foreground. And I'm going to go through a couple areas where I think this is happening. So I think it's happening in microservices. I think it's happening in monitoring. I think it's happening in data pipelines and ETL. I think it's happening in analytics. And I think that the fact this is happening across a lot of these areas, actually there's some synergy between these. And so I'll go through a few examples. So if we start with microservices, I think this is one of maybe the most important project in software engineering is how can you get the same productivity when you have 1,000 engineers working on something that you had when you had 5, right? How can you scale software engineering? And nobody really knows the answer to that question, but it kind of fundamentally has to involve chopping the problem up into pieces, right? It has to. And so the only question is, how do you do that? How do you make all those pieces work together? And the way we started doing this was really with these very synchronous request response, typically REST-based applications. And that works pretty well for a certain type of problem. It works well for UIs. It works well for interactive UIs, something that is itself synchronous. And it's no surprise that this was kind of the early technology stack for microservices, because a lot of this movement came out of a bunch of web companies that were in large part big UIs. They were kind of big CRUD applications. And it worked. It actually worked to scale engineering, but it only goes so far. And I think as companies try and interact with the real world that happens at a different pace, right, as they're no longer just a CRUD interface, as there's asynchronous things that happen in the background, as there's a more complicated company that becomes connected, I think synchronous doesn't really scale. And that's kind of led to the emergence of these event-driven microservices. So microservices that react asynchronously to what's happening elsewhere. And this allows like a much greater level of decoupling. It allows services that don't need to directly connect to the things upstream of them. And it allows the producers of these streams to not need to know everything that reacts to it. And this lives kind of in harmony with the synchronous services. If you're taking a front-end application and decomposing it, you're probably doing that with REST. But a lot of the back-end parts of a business are fundamentally acting in response to what happens. And this event-driven paradigm is really taking over. And we've seen the rise of this very rapidly. So people have only been talking about this for really a matter of years, a few years. But already, if you look at a poll Pivotal did a few months back, they found that Kafka was half as popular as REST already as a layer for implementing microservices. And that's a huge change in how people are going about this. And I think this is a huge rise of events in service design. And you're also seeing it as part of what's happening with these serverless systems. So when you think about serverless, the thrust of it is really more about getting rid of kind of unneeded infrastructure concepts, not having to manage individual machines and containers and so on. But what goes almost unnoticed is a lot of the applications people are building are fundamentally reacting to events. They're fundamentally processing some stream of events. And the use of events doesn't just go between the services. It's actually trickled into the internals. So there's been an emergence of event sourcing architectures where the internal data representation is based on the events that it's built off of. And this doesn't make sense for every application. For a simple CRUD application, you probably don't need something like this. But for really complex domains, this is absolutely necessary. And it's become popular. And this is happening naturally in the stream processing space. A lot of the stream processing capabilities in Kafka are kind of internally event sourced. And the natural representation for those events is a kind of stored commit log of what happened. And that's a lot more valuable than stitching together a queue and a store and many other things. Feeding off of that log of events is the way that this is most naturally built. And so that's in the area of application development. But events are happening elsewhere as well. So the monitoring stack is changing. So if you ask people what is monitoring about, most people say, well, we have metrics, and we have alerting, and we have log aggregation, and maybe we have this new thing, these kind of service tracing frameworks. But in a sense, a lot of the smartest people looking at this have thought, this is actually the old school. And so there's kind of an emerging idea that maybe there aren't really 4 disconnected products. Maybe there's really something underlying all these, which is events and event streams and event processing. And maybe each of these are almost an interface to that in different ways. And so what do I mean by that? Well, if you look at a log, and you think about a log aggregation, something like Splunk or any of these systems that are trying to collect your logs, what is a log? Well, it's basically a time-ordered series of things that happened. It's basically a bunch of events. And it's events about what your application did. And if you think about metrics, what are metrics? Well, most people would say, well, it's kind of a graph. It goes up and down, and it shows me what my application did. And so what's the connection to logs? Well, traditionally, there's not much of one. But if you think about it, metrics are really just an aggregation on the stream of events. You could be counting the number of errors, or you could be measuring the request latency. And so here's a KSQL query. This is something you can actually run in Kafka that's doing a type of metric computation off the raw events. And so what's the power in thinking this way? What's the power in thinking about events? The power is if you have real infrastructure around events, there's all kinds of things you can compute that you couldn't before. So instead of just defining low-level metrics on a single machine, you can actually do a much better job of defining what the real SLAs of the system are. What does it really mean to do things correctly? And checking that, like in real time. And that's a very powerful thing. And this translates even to alerting. So most people would think of alerting, you get a phone call. But what is an alert? It's an event that occurs in response to some criteria. And again, the benefit of thinking in terms of events is the ability to actually define something very rich. A lot of the movement in systems is not to alert off of low-level things like, oh, the CPU was too high, but to alert when there's real customer impact. That's when you want people to wake up. Measuring a bunch of low-level things typically just creates a lot of noise. If you can measure what you really care about, that's much better. But measuring what you really care about is more complex. You actually need a way of expressing what you care about. And so the emergence of events and infrastructure around this is really a powerful idea. And this applies even, I think, to distributed tracing. LinkedIn built a system that was oriented all around collecting all the Kafka streams from all the machines and measuring not just the latency, but the cost of those systems. What did it cost to serve a particular page view? Measuring the errors and how that propagated through these call graphs. The ability to do this came from actually thinking about these as event streams. And we were able to join on not just events that were operational, but also events that were about the user experience and what people were doing and the business impact. And that's the power of these things, is once you start to think in general terms, a lot of things that seem different suddenly become connected. And I think you can see that as we move to the next topic, which is data pipelines. This is an area with Kafka that we've talked about so much that I don't know that we even need to go into great detail. But if you think about what's happening as you pipe data between systems, this has traditionally been this kind of batch data dump, this big squiggly mess. And the power in this area comes from making it real time, making it scalable, and thinking about a database not as a data store, not as something you dump out to a text file, but as a stream of events, a real-time stream of events that anything can subscribe to, and being able to move to an architecture where all this integration can happen off a central platform. And this reduces this kind of rat's nest of one-to-one connections. And the power of this is now, as you combine these different areas, you can think about, well, what happens if I apply these monitoring-like primitives to the changes in my data pipelines? Can I monitor that? Or what if I have an event-driven application that triggers off of database changes? Or what if I have an application that feeds data out to these monitoring systems? These areas can actually interact off the same streams. So you can apply monitoring primitives not just to low-level things, but to the kind of rich customer experiences, the things that actually make you money, that you care about. And likewise, you can apply them to these kinds of data pipelines. And so the final area I'll go into is analytics. And this is an area that's actually been built around events for a long time. So one of the fundamental tenets of data warehousing is how you define your data. And the first thing you would do if you were setting up a data warehouse is you would build out a star schema representation. And right at the center of that star is something called a fact table. And what's a fact? Well, it turns out a fact is an immutable record of what happened with a timestamp. And so does that sound like anything you've heard of before? It turns out, yeah, that's basically exactly the definition of an event. And so a data warehouse is actually built around an event stream. And even the dimensions kind of evolve over time. You usually keep all the versions of it. And the ability to do analysis is really dependent on this. And I think this is interesting. I think when you see people come up with the same concept with different names over and over again, there's usually something going on there. There's usually some idea that actually makes sense. And so I think this is actually kind of a proto-event definition. Now, obviously, a data warehouse is a pretty slow event stream. It only updates maybe once a day. But still, the fact that they have a similar data definition tells us something. And as this starts to move towards a much more event-driven model, you can suddenly do real-time analytics. And the difference between real-time analytics and monitoring is actually a little bit blurry. It's actually not clear which is which. Monitoring typically means on data streams coming from low-level application data. And analytics typically means on higher-level business things. But to a certain extent, the primitives don't care what the data is. And this becomes even more important as the definition of monitoring or as the definition of analytics itself shifts. So it used to be that analytics meant making a report. And somebody would look at that report, and then they would make a decision or take action. But increasingly, the point of the analysis of data isn't to enable some human to make one decision once a week. It's to actually automatically make these decisions all the time, continuously, using machine learning or even simple rules that kind of optimize the customer experience. And this kind of closed feedback loop, it's not even clear. Is this analytics or is it a production application? I mean, the answer is yes. It's kind of both. And the demands of this type of application are very different. It's very, very data hungry. It requires you to be able to tap into primary data from databases, but also activity data that is about what people are doing. What are they interacting with? What was the outcome? That kind of event data. And so the mixture of all these data streams is very difficult. And building this around event streams makes it much easier to maintain this type of application. You'll see in the architecture diagrams of people who are building production machine learning applications, you'll see something like this picture very commonly. And so I think events are actually everywhere. And they're kind of coming out of the woodwork in all these different areas. And I think this makes a lot of sense. I think if you think about it, a business is a series of events and the reaction to those events. That's really what it is. In fact, if you ask a non-technical person to diagram out some business process, they'll often say, well, OK, this happens, and then we do this, and then that happens, and then we do this. They're fundamentally describing a series of events and the reaction to those events. That's how they would explain themselves. And so this is something that's really, really essential. And that brings us to the infrastructure for events. What's the right way to represent this? How have we done this traditionally? Well, traditionally, we haven't. Traditionally, there hasn't been much. What we've had, really, is a bunch of databases with tables. And databases are important. That's not something that's going away. It's not something that's gotten less important. But it's only half the picture. And so a table can store the current state of the world. That's how the world is right now. And that's an important thing. But events are about what's happening in the world. And there's some interplay between these two concepts. So the state of the world impacts what happens in the world. And what happens in the world impacts the state of the world. And that's a statement that's true, not just in technology. That's true about the world, right? These things have some interplay between each other. And you need both of them, and you need to represent both of them. But we've only done half. And the other half, we've kind of been faking it in the application space on our own. And by bringing these together, it's actually really powerful. And this is what's often called the table-stream duality, which sounds a little fancier than it is in the stream processing space, where if you look at the stream processing features in Kafka or KSQL, they actually allow you to do this. You can connect up to databases and treat them as a stream. You can transform that stream. You can materialize it back into other tables. You can take those tables as a stream and transform them again. And so this interplay is built really, really into the heart of how stream processing on events works. And as you put together all these different areas, I talked about services and microservices. I talked about monitoring. I talked about analytics. As you put all these together, the power of this is the ability of all these to connect. When a sale occurs, or a trade is executed, or there's some user experience that occurs, all the different things that can key off of that, whether it's a graph that has to update, or an email that has to go out, compliance or regulatory stuff, security systems that need to analyze that, the ability for all of those things to happen in reaction, that's the promise of this world of events. And that's really the origin of this idea of a streaming platform. And that's the vision that we've been building towards with Kafka, the idea that you could have all these event streams in one place, that all these different systems could hook up to this, and this could be the interchange for all the things that are happening in your company. And so I'll go through a couple of key areas in Kafka that have actually helped make it the de facto standard for doing this. We've seen companies all around the world adopting this type of architecture, and they've built around Kafka. And so I'll give a few examples of what we've tried to do in Kafka that have made this work. So the first and the best known is this kind of immutable log-centric architecture. I think this is really the data structure for streams. You have this sequence of time-ordered events. It's multi-consumer. Anybody can tap into it and subscribe to it. You can go back and reload from the beginning of time as you want. I think this is a really powerful abstraction. But it's not the only thing. So built into Kafka is really pretty deep support for tables and log compaction. And this supports that idea of the table-stream duality, the mutable data, the state that you're computing. And this is really important to bring together these two worlds so that you can take the state of the world as well as what's happening in the world. And the next thing is that Kafka has been built to be horizontally scalable. And the reason this is important is not just because there's really big applications out there that have these massive data streams. There are. I mean, if you look at IoT applications, some of them are massive. It's because it can grow from a platform that supports one application to something that supports a number of these. It can do this gradually, right? So one application kind of brings its data streams, and other applications come to get this. And it happens organically. And this can grow until it's really used across the company. It's really kind of the central nervous system that all these things plug into. And the ability to do this bit by bit is incredibly important. I think no system gets rebuilt all at once. And so this ability to scale behind the scenes as people plug into the platform is very important. And then some of the areas we've worked on a lot in the last few years is the connector architecture, the ability to actually plug in off-the-shelf systems that don't know about events, don't know about Kafka, and be able to suck out event streams from them, to be able to get off-the-shelf connectors for databases and data systems and SaaS applications. This is incredibly important to be able to just plug this in to the existing things that you have. And finally, the transactional semantics for stream processing. This has been a big deal. This is the ability to get exactly once semantics, which really means just getting correct results as you do stream processing. And this is something that cuts all the way across Kafka from what's stored in the log to the protocol to the stream processing libraries. And what this allows you to do is, in a distributed architecture, actually take input streams, transform them, maybe in a stateful, rich way that goes across messages, and produce output streams. And do that in a way that's correct, right? So one of the huge things that's held back this area of working with streams of data is you're not really guaranteed to get the right answer in the same way that you are with a batch system. The reason people were running big batch jobs at the end of the day is you either get the output and it's correct, or it fails, in which case you rerun it and you get the output and it's correct. And moving to a streaming world really requires having similar kind of guarantees that you can build around. There aren't that many programs that we can expect to get the wrong answer and still be happy with. And the ability to do this in a general way is in a way that doesn't require the application developer to have to do all kinds of hijinks to make it work is incredibly important. And so this is played out in Kafka Streams. It's played out in KSQL. It's literally just a setting you change. It's available to any of the other systems that want to integrate. And I think this is an incredibly fundamental thing. So those are 5 of the things that I think we've done in Kafka that have helped it become this kind of de facto platform for events. But it turns out there's something I think is even more important than any of those 5 things. Something that I think is actually the most important thing of it all, which is the community and ecosystem around it. So this type of platform, it isn't just a piece of software. It's something that people build around, that they're actually architecting their companies around in many cases. And so all of you who are here today, all the people who have helped submit code, all the books that are out there, the blog posts, the websites, the tutorials, the Stack Overflow answers for the obscure error messages, all of those are important. If you go onto GitHub today, there's 20,000 repositories that mention Kafka in some way. That's a ton of code. That's clients in different languages. It's connectors for a zillion systems. That's an incredibly powerful thing. A lot of that is new or experimental, but some of it isn't. And it's code you don't have to write if you build around this system and this ecosystem. And there's now over 100 meetup groups worldwide with 28,000 members. These are all people who are trying to figure out how to make this new way of thinking work, who are figuring out all the problems and all the solutions. And so I think as we look at this vision of where we're trying to go to and what we're trying to build, I think it's that community that's really the most powerful thing. I think if you want to make some big change in the world, if you want to actually rebuild companies around this type of architecture, you're going to need help, right? You're going to need a lot of people who can help you figure out how to do it. And I think that's something that we have. And it's what I'm most excited about in this conference over the next few days is getting to learn from people who have done this and everybody getting a chance to share ideas and best practices and make connections in the world around how this is progressing. And so with that thought, I hope you all enjoy this show. I'm incredibly excited to get to meet all of you. Welcome, and I hope the next 2 days are everything you hope for. Thank you very much.
You heard him. He said it's the community that's the thing that makes the difference. That is, in case you're confused about this, you. So thank you. And there's another thing. Another thing that struck me about this, and I don't mean to sound too Thomas Kuhn about it, but Jay was talking about how there's various paradigms and kind of historical architectures that we've had, and each of them sort of converges on what looks like a streaming system. And it kind of feels like there's this paradigm that we're landing on, streaming platforms, that unify a bunch of the kinds of systems we've been building around one core abstraction. And I joked before about 15 years ago when we started this. It hasn't been 15 years. Again, it's been 2. This is early days for this stuff. And you guys, if you don't mind me flattering you, are smart enough to be here and to be really on the forefront of this movement. So that's exciting stuff. Now, next up, we have a speaker I'm very excited to introduce. He is the VP of Streaming Data at Capital One. He's been there for about 4 years. And right now, all of you are thinking, VP of Streaming Data. Number one, what does he do? Number two, how do I get that job? Right? That sounds pretty good. Yeah, it's an engineering leadership role, as you will see. He's gonna talk about what's going on at Capital One. Prior to that, just to give you another idea of who this guy is, he spent about 10 years in a startup of his own that focused on mobile and big data things. Now, if you're doing the math, that gets you back to about 2002. I myself am old enough to remember nobody was saying big data or mobile really in 2002. So this is a guy who probably has some capability of looking ahead a little bit. So he's probably someone you want to listen to, and I'm delighted to welcome to the stage Chris D'Agostino.
Good morning, everyone. Thanks, Tim, for that introduction. Chris D'Agostino, I'm the Vice President of Streaming Data at Capital One. I actually live here in San Francisco, so I'm really excited to be here and talk about what we're doing to help enable an event-based architecture and basically transform the business of banking within Capital One from what most people think of banking as historically like not real-time, batch-oriented, and somewhat antiquated systems. So I think you'll find what we're doing to be really exciting. So I want to talk to you today about 4 things: the motivation behind this event-based architecture that we've built out, where we are kind of in that process or in that journey, talk a bit about the streaming data platform that my teams are responsible for, as well as some of the data management tooling that we're doing around event processing and event governance. Resiliency, big issue for us, right? We are a federally regulated organization. Like all banks, we need to not lose data, so we need to make sure that the systems that we build out can scale and stay up. And then finally, on that topic, the software development kits that we've built to enable people to stream more easily, both producers and consumers. And then we'll talk about when you're working in an organization where we're in probably 5 or 6 different cities in the United States. We've got nearly 10,000 software engineers, 40,000 employees overall, roughly. We need to be able to scale out, and we need to be able to make it very easy for people to produce and consume data, whether it's stream data, APIs, or what have you. And then finally, as we move towards this sort of fully robust event-based architecture with thousands of events flowing through the system at any one time, or thousands of event types flowing through the system at any one time, what we want to be able to do is basically, as Jay was talking about, react to these business events in an if this, then that style. So we'll walk you through that. So for those of you that are Capital One customers, you may have been enrolled already for our Eno digital assistant. You can think of it kind of like the Amazon Alexa for Capital One. It's basically a real-time, intelligent, and automated digital assistant that's basically looking at not only your transaction history, your spend habits, applying machine learning algorithms to determine what transactions and what types of behaviors make sense for you as an individual customer, but that capability is completely dependent on events streaming through Capital One. And so we've got 4 different lines of business. We've got, as you may know, obviously the credit card division. We've got a banking capability, commercial banking, and then we have an auto loan capability or line of business. We tie those together in terms of a unified customer experience through a digital organization, and then I'm part of what's called shared tech. So we're an enterprise service arm of the company that builds out enterprise platforms that are to be used across the entire company. So in order to do this, and make Eno what it is today and further improve it as we move forward, we need to be able to identify events that run the business, identify events that are meaningful to our customers, and instrument these source systems that are traditional sort of n-tiered applications, instrument these source systems to emit these events. And so everything from clickstream events in our mobile application, our web application, everything from our internal systems that generate business events when payments are posted against accounts, when money is moved between accounts, all those events get triggered and flow through this platform. So let me talk to you a little bit about the goals that we had when we set out to build this. So as I said, we're based out of Washington, D.C., or McLean, Virginia. We've got offices here in San Francisco, New York, Richmond, Virginia, Plano, Texas, Chicago. We're in Toronto. So you've got engineers spread across the entire company that represent the engineering efforts and systems that are being built for these discrete lines of business. So the first thing that we wanted to do was make sure that we had a consistent approach to how we built out a streaming platform, and that each team didn't go off and build their own style, whether it was Kafka or some other streaming environment. We settled on Kafka for all the reasons Jay has mentioned, but we wanted to make sure that we were being really consistent, rolling out upgrades in a uniform fashion, and making sure that we had a similar dev, QA, and prod environment, so that as you moved your streams through those different environments, that you got the same sets of results when you finally went into production. The second thing is producer autonomy. Each of these lines of business are responsible for their own P&L, and so what you don't want to have happen is some issue on the card streaming version of this card streaming platform, or that segment of our streaming data platform, affect other lines of business. And so we needed to determine how to set up a topology where we could have consistency in the way that the platform is rolled out, but also isolation and control of blast radius. Likewise, because of regulatory requirements, data sharing between lines of business is regulated strictly and needs customer consent. And so you've got an additional layer of data management capabilities that need to be put on top of this. And those tools are also built by teams in my organization. So we are tying all of this together as a sort of a governed platform. So the data governance piece of that, the third item here, is really making sure that producers have the accountability for the data. We want to make sure that we're not doing traditional things like you saw in data warehousing environments, where data would just go in, the data might be messy, you're running a bunch of ETL scripts to try and clean things up, maybe you're normalizing date timestamps and things like that. We wanted to make sure that we got out in front of that with this streaming environment and get all those records uniform, consistent in their formats, data quality checks applied before the event even makes it into the ecosystem. And then finally, with the idea of data flowing in real time, it generally, and it flows through the streaming data platform, it gets aggregated up, it gets deposited into our OneLake environment. Some traditional analytics happen there where it might get loaded into things like Redshift or Snowflake. But that time between when the event fired and the time that it gets finally loaded into traditional data warehousing techniques is far too long for a business to operate the way that we want to operate. So we need to be able to react to these events in real time. We need to be able to do things like joins and aggregations and filters on events. And so we'll talk more about that as we move forward. In order to get people streaming, obviously when you build an enterprise solution, for those of you that are in that kind of part of an organization, you need to really worry about adoption. You need to make sure that you make the platforms as simple and easy to use. You do a lot around communication, a lot around building out capabilities to ease the burden of onboarding onto these platforms. And so what we have done at Capital One is we've created a single exchange inside the company that developers can go to either produce APIs, produce streams, discover APIs and streams that they might want to leverage in their applications, and I'll walk you through what that feels like as a user to define a stream in real time. So for a topology, as I said, we're running credit card transactions, we're running money movement, payments, things like that flow through this environment, so the system cannot go down. And so what you're seeing here is what is a standard sort of blueprint for when we build out a cluster. So I want you to think about our environment as 2/3 physical and 1/3 logical. So the 2/3 physical is we're building out discrete clusters that represent and provide capability for streaming for different lines of business. And one line of business might have multiple clusters, for example, depending on the number of streams and the amount of data that flows through. But what we need to be able to do is then also ensure that none of those go down. And so the topology that we've landed on that we feel really good about is we'll build a cluster. A single cluster on your left in one region will be split across multiple availability zones. And then we will replicate using Kafka Connect the data to a an identical cluster set up in an opposing region. And we are a multi-region, multi-cloud company, so this is one example with one cloud vendor. We've got similar topology for other cloud vendors as well. But what happens is when you go through the workflow, which I'll show you here in a bit, and you define a stream, because of the resiliency requirements, we will automatically provision that stream in region 1. We'll configure that stream in region 2. We'll configure the replica of the streams, and then with our SDK, as a producer or a consumer, it really doesn't matter which broker you're talking to and which partition you're writing to, because we keep track of all that and we dynamically switch between them. So Capital One's known really well in industry with its focus on customers and the user experience around how we treat our customers, not only in terms of our banking policies, but also with our mobile app in particular. It's been an award-winning app for years and continues to be at the top of the fleet with J.D. Powers. So we need to be able to bring that same type of design, that same type of empathy research to our internal users and make sure that when they're trying to do their jobs, they have as good of an experience as our actual customers do. So, but you've got to be able to govern it, and as an engineer myself, like nobody wants to be told this is how you have to build software and this is how you have to define an event, but if you're going to do that at scale, you've actually got to apply some governance around it, but make it as simple as possible. And we haven't completely eliminated the human being from the review process. I'll give you some metrics as to where we are now. We've been at this for about 1.5 years now for the overall platform. But when you go into the planning stage and you define the stream, we've got some very strict guidance that says only the system of record that is the authoritative source for a piece of information is able to stream that data as the author. If you restream that data, maybe you create a composite stream or something, you will have to, the SDK will automatically give attribution to the parent stream. And this is part of the data management tools that we're working on. I won't go into too much detail there, but it's part of the lineage requirement of being able to trace back, no matter where a piece of data is being used in the organization, be able to trace that data back to the system of record that it came from. So the design, we go through a user experience where you go through, you describe what your stream would look like in a JSON format. We have a naming convention. We validate that the names for the streams are available and not being used already. We have data quality rules. So as I mentioned, we want to make sure that the events that go into the ecosystem are healthy events. So we will run data quality checks against those. We'll watermark the data since they're immutable records. If you then leverage that data later, you can check that watermark with a very quick calculation, and if that matches, you know that the data is what was intended to go into the system, and you can rely on it. We go through a design review for the stream, just making sure that we are taking care of NPI and PCI data, and we're tokenizing it, we're encrypting it so that the data is secure for our customers, and then we deploy the streams into the dev, the QA, and the prod environments. So here's what it looks like if you're going through the planning. This is like, I'll build up the screens here, but you basically go through, you define the stream name, you define the engineering teams responsible for creating the stream, so we have attribution back to who we need to talk to in order to get streams adjusted if need be, or the consumers can go in and look at the stream catalog and figure out like, hey, this stream doesn't contain a field that I think it needs to contain, and you can work with them. We have the capability to version streams, have multiple versions running at the same time in production, sunsetting the prior versions over time. You do the stream definition in a JSON editor, and what you can't really see down here is the ability to start applying some rules, but within the user experience, we basically walk through and you can check for values to make sure that they're not null. You can do regular expressions. You can look for specific ranges of values that the data needs to satisfy. Then we provision the stream into both the dev and the IT environment, and IT is our internal word for QA. And what happens then is we basically create a configuration file and we give you an SDK, either in Python or Scala. There is a Spark library that we use since we're a big Spark shop as well. And what we do is that configuration basically sets up all that capability for being able to talk to brokers in multiple regions and be able to partition, send topic data to the right partition. And then once you go through the design review, and you've been at this point in time as an engineering team, you've been testing your code in both the dev and the QA environments, and in the background, the design review team for the stream definition has reviewed your stream and made some adjustments with you potentially. But once you do that, you're now in production, and then you just sort of rerun that loop for new streams, or if you want to iterate on the existing stream. So we came up with a standards document and basically described an ontology. So what we wanted to do is we wanted to make sure that events were consistent in terms of their semantic meaning. So if you think about the CRUD operations for things that might happen in an organization, you could create something and use that semantic meaning. You could call it new. We wanted to make sure that we created a finite enumeration of values so that when you went through, it became pretty easy for you to describe what that stream was designed to do. And then you can see down at the bottom, we're checking the availability of that stream definition. And so if you were to go to our stream catalog, just reading it as an end user, the streams intuitively make sense. So let's talk a little bit about the SDK features. I touched on these a bit, but we are using X509 certificates to authenticate people from systems from a producer to the SDP platform or for a consumer. And so all that dynamic, certificate generation, all of that stuff takes place inside of our SDK. The SDKs just basically wrap the native Kafka SDKs, but we do additional things like the data validation rules. We check the schema. We have the secondary support for producers, secondary cluster support for producers. So if you are a producer, you don't really need to worry about whether or not you're talking to a cluster that's in the East region or in the West region, or if the East region goes down for some reason, it dynamically switches over. We keep track of the offsets for the producers and consumers themselves, or for the consumers rather. So how are we doing in terms of rolling this out and getting adoption? So we have 1,500 streams that have gone through this process. We are continuously evolving the user experience and the workflow associated with defining streams. We're trying to get machines to be more involved in validating the schemas and things like that and take the human out of the loop. But for now, since, again, we are a regulated organization, we want to make sure that we're really cautious. But we have over 27 billion events that have flowed through the environment to date. And that doesn't even include some large swaths around our cyber capabilities that once that data starts flowing through, these numbers will skyrocket. So stream design, 75% of the streams are designed within 3 days. And you need to think about, those of us that are here at this conference are either used to streaming and have a really good sense of how you might instrument a producer application or how you might instrument a consumer app to read and react to these streams. For us, it's been a bit of a journey to teach people and to go out to the sites. We have road shows where we go to each of our locations and we work with the engineering teams. We have tutorials that we've set up. So within Capital One, we want to make sure people are streaming in a particular way, and we want to make sure that they're following all the governance processes that they need to. The stream review, so it takes about 2 days. I know we tend to be an impatient bunch in terms of the engineering community, but 2 days to get a stream reviewed and approved so that you can actually start emitting events that people can consume and react to is not too bad. And then it takes us less than 2 weeks to get streams out to the production environment at this point. So we're always looking to improve that. So here's an example. This is a project that I worked on when it was a batch-oriented project. This goes back a few years. And for those of you that are Capital One customers, you'll know what second look is. It's basically, as it sounds, it's a second look. So a transaction that you've performed with your credit card or with your ATM debit card, that transaction, once it's approved, it's not viewed as fraud, but we're not quite sure whether or not that transaction is something that would be, that you'd be concerned about. So for example, if you went to a restaurant and the bill was $100, and we know based on your spending habits in the past, you typically tip around 20%, let's say the tip comes in at 40%. The second look algorithms will pick that up and notify you. But in the past, it was done via a batch process. So we would run these things nightly. Customers love it. You see the 90% score when we do the surveys down there in real time, or not in real time, in the feedback surveys from the emails. But the emails, we were sending out a lot of emails because a lot of these algorithms were triggering. So double swipe algorithms. So if you went to a merchant and they swiped your card twice, most people, myself in particular, I'd never notice that. I don't go back and look at my statement and try and see if Starbucks or somebody charged me twice for a cup of coffee. But what we can do now with the platform is, in very simple orchestration with emitting events, we make 3 RESTful API calls. The algorithms trigger and give a result, and then we can alert the customer in real time. So if they were charged twice in a particular store, and in this example, it's like a bicycle shop or something, if they were charged twice, all they would need to do is just go back to the cash register because the alert came in probably before they even left the store. So, and this is all running through the streaming data platform. So where are we headed? We look at events, as Jay described, as basically running our business. And when you talk to business people within our organization, they talk about wanting to be able to react to events if certain events take place, and oftentimes it's a combination of events. So a very common fraud case in financial services is if somebody calls in to a call center and updates their home address or a shipping address, and then someone goes through the self-service app and requests a new card, say that their card was lost or stolen. So now somebody has done an account takeover. In most banks, including us, these are discrete systems that don't talk to each other necessarily in real time previously, but now they do. And so when those events take place, our fraud algorithms are looking for a sequence of events that take place. But even today, we are still in the position where both producers and consumers need to read those events in and need to be able to react to them in their own code base. And so that requires software engineers to go in and change the code, change the rule sets. Do they do it consistently from one project to another? Not sure. From one line of business to another? Definitely not sure. But what if you provided a layer on top of the event platform that allowed them to define an IFTY-style rule? And because we have the schemas and because we have the event ontology, we're able to have people be able to basically say, yeah, these 3 events and these attributes within the events, we want to be able to just describe a rule based on that and trigger a RESTful endpoint or trigger a notification to a customer if the constraints were met. So, in order to get us there, one of the things that we're doing is creating this concept of a lens. And so the lens is being able to go through and describe how you might join up different events, what attributes you care about within those events, and then we are really excited about KSQL as a capability of being able to basically write a select statement, if you will, against that and create one of these virtual tables that the events would sit in and make those results available sometimes as another stream, oftentimes as another stream, but sometimes as an API. So if you think about windowing and you might want to look at, say, a customer's session data on the mobile application, they spend about 7 to 12 minutes per session at most when they're going through and looking at transactions. That's sort of the long end of it. And what if we wanted to be able to trap those events, look at that session data, and look for things where they might have gotten stuck? Perhaps they tried to make a payment or move money between 2 accounts and then they abandon it. We wanted to be able to not have to wait for that data to go into the analytics store where we would process that, because by that time, excuse me, by that time, the customer is off the application and not using it. Or if they call into our customer call center, we want to be able to say, hey, this is exactly what you were doing when you called in, and so maybe we can really short-circuit the support path for you. So we want to be able to create these tables of events, have windowing against them. We want to either emit those as a new stream, sometimes it's filtered, or we want to be able to have that fronted by an API, a coarse-grained API. But this also allows us to create filters. Say, in our authorization request stream, we've got 3 different credit cards. You've got your Quicksilver, Saver, and your Venture cards. If we were really only interested in Saver transactions that were greater than $300 for a set of accounts within a particular zip code and a radius around that, we can do that with this type of platform processing. And so here's an example of what we're doing. We call it sort of taking the fire hose and creating the garden hose. So we've described a rule that says we want to be able to look at transactions for accounts that are of type XYZ and whose dollar amount is greater than or equal to some threshold. And so you'll see we selected the 3 out of the 4 transactions that matched XYZ there, and then we create that and we're able to react to those events. So again, being able to do this in almost real time as opposed to waiting for the data to go into the lake environment and pull that data from there. For those of you that know what IFTY is, you see it a lot in home automation. So when you arrive at your house, the garage door might open, the security alarm disables, the lights turn on. We want to be able to do something similar to this inside of Capital One. This is not a platform that is commercially available, so what we're doing is we're in the process of building teams in San Francisco, DC, New York, that are going to help us be able to build out this type of platform. And here's a quick look at the architecture. So this IFTTT rule engine is really the heart of the engineering effort that we're working on, but everything that's going to feed into this environment comes through this streaming data platform and is backed by Kafka. And that's all I've got.
What I love about that, just as a sort of a personal note, is what I do and what my team does is we're often involved in helping people get started with this stuff. And like I said, I know a lot of you here are just getting started building streaming systems. It's really neat to see at scale what it looks like when a platform like this reaches a certain amount of maturity and the things that develop. Like I said, you want to keep an eye on that. And these are maybe the kinds of structures that some of us might be building in a few years. Also, all of the end user facing stuff, this is completely uncoordinated, but I happen to be a Capital One customer. That stuff actually happens. Like, hey, did you just buy an SD card in Paris? Because that's kind of weird. And I'm like, no, that was actually me. It's okay. And it goes forward. So good stuff. Anyway, another show of hands, and the last one for the morning. Who, since I gave you the hashtag before the 2 keynotes, who has tweeted or Instagrammed a picture with this hashtag? I want to see your hands held high. Excellent. Excellent. The rest of you, I'm confident that you have smartphones. So you should use them. Kafka Summit is the hashtag. It's not even hard. It's not like Kafka Summit SF or 18 or anything. It's just Kafka Summit. So the Instagram, the Twitter, some pictures, and remember, we're going to make a poster out of these things, and that's going to be pretty cool. So make sure to check that out. And now, we're just about to be dismissed. We have a half-an-hour break. Sessions start at 11. We have a half-an-hour break. You can get a snack. You can get coffee. You can visit the expo floor. You can talk to your friends, whatever it is you do. You are dismissed. Thank you.
Thank you for attending the Kafka Summit San Francisco keynotes. We'll enjoy a networking break before starting sessions at 11 a.m. Then we'll break for lunch at 12:35 p.m. Please check your mobile app for all schedule details. Enjoy the day.